All right, welcome everyone. Thanks for joining us today at our current April session of the Earth Engine User Meetup. We will give people a few minutes to log into the live stream. We're really excited today to welcome our guest speaker, Kristen O'Shea from the Desert Research Institute, and she'll be talking about Climate Engine tools for analyzing climate and remote sensing data. So as folks trickle in, I'm going to share a few slides to tell you a bit about the Earth Engine User Meetup and what to expect in the next few months. So the Earth Engine User Meetup is a free and open monthly meetup for users by users of Earth Engine. And we welcome anyone who uses Earth Engine for work or their research to come and share what they're doing. And regardless of whether you are just at the beginning of your journey using Earth Engine or you've used it for a really long time and you're an advanced user, we welcome you to come and share with us what you're doing, any issues you encounter, some tips and tricks for other people to learn from you. So this is what we do at the Earth Engine User Meetup. We typically have a speaker share a talk, and after the talk, we have some time for question and answer via Slido. So why should you be a speaker? It's a great way for you to share your knowledge with other people, as well as help others who may be encountering the same challenges as you are. Because we know Earth Engine might be challenging for some people to start learning. And along the way, you may have picked up some useful knowledge and skills that you can then pass along to others. It's a great way for you to practice public speaking and communication. Explaining what you do really helps you also solidify that knowledge, and it helps you grow your personal brand online, which is very useful for your career. So for future information about meetups, we have a newsletter at ThriveGeo. You can go to this bit.ly to sign up for a monthly newsletter, and you will get the links in your mailbox. I also share these links via the Google Earth Engine Developers Forum. And you can also subscribe to our YouTube channel at Earth Engine User Meetup to watch the meeting recordings afterwards. Because we know not everyone can log on live. So this is a great way to stay up to speed as well with the events. So we're really excited to have two speakers lined up for the month of May and June. In May, we are excited to welcome Emma Esquedo Verdigier from Boku in Austria. And she will be talking about analyzing the impact of climate change on spring onset, new continental scale data for its understanding. And this meetup is on the 10th of May from 12 to 1 p.m. UTC. So mark your calendars and join us for the next Earth Engine User Meetup. In June, we are really excited to have Samapriya Roy, who works at Maxar, and he's also the curator of this awesome resource, which is the community datasets. And he'll be speaking on the 14th of June from 1 to 2 p.m. UTC. So get those dates down, and we look forward to seeing you at one of these next meetups. And of course, if you would like to speak, please don't hesitate to send me a message via LinkedIn or email anytime. You can write to us at contact@thrivegeo.com, and you can let me know what topic you'll be interested in talking about. I'd love to put you into the calendar. So without any further ado, I'd like to welcome our guest speaker, Kristen O'Shea from the Desert Research Institute, to give us this awesome talk on Climate Engine, where she'll also be doing a lot of demos where we can see the tools live. So thank you, and over to you, Kristen.
Awesome. Thank you, Sabrina. I'm going to share my screen and get all set up, and then we can dive right in. It's great to be talking to everyone today. So I'm going to be covering Climate Engine, which is a set of tools that were made for analyzing climate and remote sensing data. And the reason I'm doing it in this forum is because these tools were built on the power of cloud computing and Google Earth Engine. So before I hop into the tools, They were actually founded at the Desert Research Institute, which has research that is focused on humans' impact on the environment and the environment's impact on humans. This includes research on air, water, earth, and fire. So if we rewind back to a little bit of background, if we rewind back to 2014, climateengine.org is founded at DRI by Justin Huntington through one of the faculty research awards. But it was actually a bigger team of scientists that came together, and they had the idea that there had to be a better way to work with this data than downloading it locally. Sometimes you have to get full swatches rather than being able to focus on the area that you're looking at. Also trying to make it easier to have access to this data without necessarily being an expert in how to process it, how to find it, download it, host it, all of those things. 2 years later, Climate Engine publicly launched and was on the cover of the Bulletin of American Meteorological Society.
Since then, they've extended their functionality, working in collaboration with the Navajo Nation and NASA for a drought severity evaluation tool. There was a company that came out of this.
In 2021, the Climate Engine API was operationally used to produce interactive drought metric maps for drought.gov. And then most recently, last year, we relaunched climateengine.org altogether with enhanced user support, more data sets, enhanced functionality, and that brings us to today. So wanted to highlight, this is a really big team effort. It's made up of research scientists and professors, software engineers, and then data engineers and data scientists. Highlighted here. We actually have our Earth Engine Gold developer on our team, Eric Jensen. So really getting to what is Climate Engine. Again, it was this vision of doing all of the computing in the cloud and making it easy and accessible for researchers not to have to be expert on how to create a drought map, but being able to pull the data for drought maps or any kind of climate remote sensing data, summarize and unpack it via maps or time series, and be able to use it in their research and decision making. So an example of this here on the right, we have the Earth Engine code to create one of these drought maps. So you can see quite a bit going on there, maybe to the expert user, not very intimidating, but someone new to using this type of data or coding in Python or JavaScript, it could be. So if we could take all of that into the back end of some type of tool and provide a user GUI where in 4 clicks, you can get an output that is downloadable, interactive, that you can share. That was really the vision behind Climate Engine. So I want to highlight some of the application highlights. We've been partnered with NOAA and BLM, and they've been some of the biggest supporters of the development of the Climate Engine tools over the years. Here, NOAA NIDIS, as I mentioned before, they operationally pulled these different drought maps from Climate Engine using the API and display them for users at drought.gov. The Bureau of Land Management, a lot of different initiatives going along with them to look at vegetation and drought monitoring for rangelands and how to use different workflows within Climate Engine. One of the ones that I'm going to show today to be able to evaluate and monitor different interventions. Climate Engine also has a really powerful it's really powering storytelling. So I have an example here on the left where data was pulled from Climate Engine on anomalies for NDVI, and they were using it to assess crop conditions and convey the story of how drought is impacting a certain area and how the people are being impacted by that drought. A second example was the Wall Street Journal using Climate Engine to pull anomalies for temperature data to be able to communicate just how impactful July temperatures recently have been relative to historical values. And so it's really cool that the awesome GE community catalog is going to be featured as part of one of the talks. So Climate Engine doesn't just want to enable people through our tools to be able to use the data, but actually teamed up and contributed 29 different data sets that Climate Engine has ingested to the community catalog in hopes that it would allow people to unlock the potential of having these data sets in the cloud and the tools to be able to provide insights from them. And so there's a Medium article for anyone interested in digging more into that. So I wanted to start with going over the web app. So there's two tools I'm going to talk about today and give demos on. There's a user interface, which is the web app. It's free to users. And then there's an API that allows users, it's a little more involved, not necessarily a no-code solution, but it allows users to scale their analyses and pull larger amounts of data in a more systematic, programmatic way. So here is kind of a schematic of how the web app works for Climate Engine. So for the deployment, that big team of developers and scientists I showed before, they're going to be using GitHub. They're going to be running tests, updating functionality. We are constantly creating new endpoints to meet our users' needs. I'm going to show one of our newer ones off today. But once they are working and they submit a new update to GitHub and they merge it with the master branch, GitHub triggers a cloud build to create new containers. And so it's going to build up the app and it's going to deploy it using Cloud Run. Here's where Cloud Run is going to authenticate to Earth Engine with our project specific credentials, noting that containers are portable to other organizations' cloud infrastructure. And that's currently happening with NOAA right now. And so once we have that deployed application, the backend is going to be powered by Google Earth Engine and Python, using some core methods that a lot of you are probably familiar with, but then building out a front end that has these really user-friendly forms and visualizations that allow for quick insights into this data. So now I'm going to go through my first kind of set of demos. So I've logged in already to the Climate Engine app. You can sign up for free. Just go to app.climateengine.org. It runs all in the browser. So this is what it's going to look like. There's going to be, again, kind of two ways to unpack this data. You can either make a map or make a graph. We'll go through making a map first with some examples. So it's broken down into these different sections where you have to pick the data you want to work with, how you want to process that data, and then what time period you want to visualize it for. We have 4 different categories of data sets: climate and hydrology, remote sensing, hazards, and forecasts. And so you can kind of click between those and it will populate different data sets in those categories. It sometimes can be overwhelming. We have a lot of global and specific to CONUS and North America data sets. So working through it can be a little hard to know what data set you're interested in, but if you click these little question marks, they will actually take you to pages in our support site where we give you as much of the information as possible to make decisions on how you want to use that data set, if it's a right fit for what you're trying to do. For my example, I'm just going to keep it on GridMet, and all of the data sets are going to be formatted data set, spatial resolution, temporal return resolution. Next, it's going to populate all of the available variables. We have them grouped under some categories to help you go through it. And then if the data set has variables that go into different calculations, such as drought indices, we're going to calculate those also for you. And we'll just leave it on precipitation. For now, keeping it really simple as we start and move to the processing tab. It allows you to pick your statistic over your day range. For something like precipitation, total is going to be the option because you'll want to add the amount of precipitation together. But sometimes for other data sets, it will give you mean, median, min-max, all of those. Next is the calculation. So this is where you can just look at the values of the data sets, but you can also do different calculations such as anomalies and trends and standard indices. And then lastly, you're going to want to pick the time period you're interested in. We have some pre-computed time periods that are useful: last 15 days, last 30, last 60, last 90, and then different groupings of time periods throughout the year, water year, calendar year to date, entire period of record. I'm going to pick last 15 days of data and click Get Map Layer. So it's going to process that request and then visualize it here on the window. So it's always going to tell you kind of what it's representing here. But we see it's March 26th through April 9th is the dates that it pulled data for. And then it took the total of those values and visualized them here. There's some editing that you can do if you want to change up the visualizations. So we have different color palettes that you can pick through. I can pick, you have divergent, maps, sequential. We'll just pick the blue sequential. And then you can also edit the values on the color bar. They're not always going to be exactly what you need to visualize and understand what's happening with the data, but here we go as it's updated. And you can see a lot of precipitation in Eastern Ohio, Southeast or Southwest Pennsylvania. Some of the other things that you can do is you can adjust your base map. You can't really see the difference for that, but you can go through and change the base map. We have a lot of layers that are uploaded. So if we're interested in the hydrologic unit codes, you could click those to add to the map, and you can zoom in to an area we're interested in, maybe over here where we've had a lot of precipitation, and you can click and it will give you the name and HUC ID for that HUC 8. So we have a lot of different, we have fire perimeter layers, different world layers that you can explore. Masking, so maybe you want to mask out certain areas below or above a value. So you could use those different options there. When you click on one, it'll give you input options, and then you just update the map layer. And then lastly, you can download the map in two different ways. You can download the raster data in a GeoTIFF format. That does have a limit. You're not going to be able to download NDVI for the entire US, but that's where you would maybe want to look at the API and options with that, or you can download a map image. So we'll zoom back out. So it's really great to see what's currently going on with precipitation, but maybe we want to know what it's like relative to historical. So we could pick one of our anomaly calculations like difference from average conditions. We could update the time period. So let's say the last 30 years. And so it's going to calculate that average and then what the last 15 days of data is versus that average over time. And this is a little bit more of a complex computation, so it takes a little bit longer, but we can see the outputs here. So in those darkest areas, it's almost 100 millimeters above the average over that last 50 years or 30 years. And you can see, again, that information there. If I was doing this analysis and I wanted to share it with a colleague or put it in a presentation, you can click link, and this allows you to share the map. All you would have to do is copy that and then send it through your email, and they can open it in a new page, and it should take you right to the map that you were creating, so they can look into it and do their own investigation. And then not all options maybe give you all sides of the story. So we know that it's a lot more than that average, but where does it sit in percentiles of the past observations? So we can change to that also. Again, a large calculation might take a couple minutes. And it will start populating here. So not only is it quite a bit more than the average, but it's in the top percentile. And while that's happening, actually part of the Midwest is in the bottom percentile for precipitation. So next, just to keep moving, I'm going to throw a lot at you guys, but I just really want to get all of the cool different ways to start thinking about this data and visualizing it through Climate Engine. So if we switch gears and we want to look at drought data now, we can go to a new data set, GridMet Drought, and it's going to populate all new variables. We're going to have things like the standard SPI, which only takes into consideration precipitation, SPEI, which takes into consideration precipitation and evapotranspiration, and then EDI, which is just evapotranspiration, then also some long and short-term blends. So can just grab the last 90-day SPI. We're going to leave the processing alone, and then it'll just pull the last end date that has data for. So you can also start digging into these drought metrics. And while we saw that precipitation was really low percentile for the last 15 days, it is drier than normal, but it's not matching the same exceptional. You might have thought, oh, it's exceptionally low precipitation for the percentile. Maybe it's exceptional drought. And in some places it might be, but it's not as far spread. So you can kind of start digging into those dynamics. I'm going to transition now. If you wanted to look at drought for a specific area, we'll start with our first graph that I'm going to demo. I'm going to pull a native time series. You have the option between summary, which allows you to pick like a certain time within the year. So if you want to just look in the growing season, you'd pick summary time series, and it's going to do a reduction. And then it's going to pull the time series and drill down through that stack, whereas native time series is going to pull every value in that stack. And then 2 variable scatter plot. We're going to do a 2 variable analysis. Once we've picked the type of time series, we're going to want to move to the region. We have a lot of different options. You can do points, polygons, upload custom shape files, and then also choose from some pre-selected regions. I'm going to show one of those. So if we go to US regions, again, I'm going to pick the Huck 8 that we were just looking at. And then I'm going to scroll down to pick the Hot Creek Railroad valleys, Huck 8. And there's a lot here, but there we go. So it's going to zoom into that area that we picked. So now I want to be able to graph 2 variables. So I'm going to look at the short-term drought blend first. We can adapt these, but I'm going to keep them how they are. And I want to pull the last 12 months of data. I'm going to do the same for variable 2. Pulling the long-term drought this time. And so this is going to process and pull all of the data for the last 12 months and plot these 2 different drought data sets on the same chart here. And so it's going to take a second. I can kind of explain. Once it's plotted, there's things that we're going to be able to do, such as play around with the axes a little bit. You can add different statistics to some of these plots. And you're going to be able to download a CSV of all the time series data, PNGs of the plots, and also share links like I showed before. And this is going to take a little longer because it's doing a standard indice for the last 12 months for both these data sets. But here we can see the outputs. The problem is it's a little hard to read it on these different axes. So what we can do is go to graph. We can also change the type of plot, but we'll leave it at line for now. I'll put them on the same axes here. And so we can see that throughout time, we have the long-term blend, which is actually pretty out of drought for that time period. So we're going to see anything below 0 going towards this way, going towards like negative 2.5 being more exceptional drought. So we had some areas, maybe January of this year, that would be considered in drought for this area. And I'm guessing there was a big precipitation event in September that brought this short-term drought up, and it spiked, and it even pulled the long-term over time. But yeah, if we go here, you can see all of our download options. You can go to the data tab and see the outputs. And that's kind of what I had prepared to look at some of the functionality of the climate data. I'm just going to click reset for the next set of demos, quickly go through some NDVI, and then switch to talking about the API. And so I like to just reset, because when you get too far in, if you're making a lot of requests, things might get caught, or you might not see the results you're expecting. So it's good to kind of just start fresh. If we go to remote sensing this time, we can see that we have different Landsat, MODIS, and Sentinel data sets available, but then some different derived products, OpenET, the different rangeland analysis platform, fractional cover data sets, some of the ET data sets. We'll be just sticking with Landsat surface reflectance. And then we have a lot of different variables, composites, bands, ratios. We'll stick with NDVI. So I want to zoom into a riparian area here in Nevada. And so here we see some agricultural fields along some riparian. And what we can do is we can look at the last growing season of NDVI values and click Get Map Layer. So you're going to see the higher productivity in both of these areas. We can't really tell the dynamic that's going on. So we can dig in deeper with some of our calculations, this time looking at the slope of trend. We have some p-value mask options. I'm going to pick 95% confidence, and then we'll go for the historical range. So this is going to show those significant trends in the different areas. And we're actually going to see, as it fills in, that this riparian area is undergoing a negative trend in productivity, while the different agricultural fields are showing a positive trend, which makes sense. You have pumping, and you're artificially giving those areas water for NDVI. If we wanted to dig in even further to kind of what's going on in that trend, we could go to Make Graph. We want a summary time series because we want to look at the growing season. So I'm going to go June through August again. We're going to go to a polygon, and I'm just going to draw a little box right in this area. It's automatically going to add the variable that I just had on the map. And then we'll just go 1990 to 2023. And so now it's going to pull all of those yearly values, and we can see that trend of after 2006, that sustained drop in productivity in that area. And so a question you may ask is this just because of it was these dry years and that area is not getting enough water fed into the system? We could always go to a two-variable analysis and add precipitation as the second variable for the northern water year. Match those time periods up, and then add precipitation. And there's more investigation you could do. Just for the sake of time, I'm going to keep things moving. But we can see, well, we did have some dry years. We had some greater than average. So it's going to be average is above average is blue, below average is yellow. Same with the bar charts. Above average is green, below average is yellow. So we had some above average years, and you still saw some sustained lower productivity. And so, yeah, that's kind of the demos on the app. I'm going to transition so we can dig into the API. So we'll start the slideshow back up. So I know we have different levels of experience here, so I may repeat things that you already know, just stick with me. So the Climate Engine API provides, again, kind of that programmatic scale ability to request this data. It's going to cover all of the functionality that the UI has, but then also some additional, and I'll show some of that today. An API is an application programming interface, and it allows different types of softwares to communicate with each other. It's crucial for connecting systems that are otherwise unable to interact with each other. And the way I like to think about this is when you go to a restaurant, it's not just obvious how you can communicate to the chefs what you want. So you're going to have something like a menu that it's a certain protocol or set of parameters that you're going to pick to order your food. And then in the kitchen, they're going to know exactly what you're asking for based on how you put in your order. So that's how I think of it. Similar to the app, so the developers for deployment are building the functionality to GitHub, and then it's building out the API and Cloud Build and deploying with Cloud Run, authenticating to Earth Engine. You can visit our Swagger page via the browser. This is going to be that no-code solution to have some of these scaling capabilities or additional functionality. I'm going to show that. And then also you can access it through programming. We have both Python and R examples on our support site. There's going to be quotas working through our Earth Engine credentials, but then also we're working to allow users to authenticate to different Earth Engine accounts to remove those quotas. The quotas are only for exporting raster, but time series you can run without them. So for the Swagger page, you would head to api.climateengine.org. You're going to want to check out docs.climateengine.org. That's our documentation. So that's kind of like the menu in my example. So without the docs, you really wouldn't know how to tell the API what kind of data you want to request. We have a lot outlined there. So once you have those two things, you're also going to need a key from us to be able to run requests through the ClimateEngine API without authenticating to another account. But that's really easy. You can submit through our support site and make that request. So once you do that, you authorize using that key. You're going to go to an endpoint of interest, click the try it out button. There's going to be some default parameters, but you can fill them out using the docs page and you execute. So you can either get the results, it'll show them there, or you can export them to Google Cloud Storage. I'll be showing Colab Notebook as the demo. So making some requests through that, you're going to want to import any packages you want to work with. So the time series, it's going to return it as a JSON. So if you want to work with that, turn it into a pandas data frame, which a lot of my examples are going to show. You're going to want to import those packages. You're going to want to prep for the API call, being able to tell them what URL, what parameters, and making the request. So I'll have some demos on that. And we'll move to that right now. So when you go to docs.climateengine.org, I'll just read. It's going to bring up this page. On the left, you can kind of see all the overview, registration, how to get authentication. Here's going to be all of our different endpoints. The maps and time series are going to be very similar to the UI, but then we have additional zonal statistics and probability endpoints. We have the data sets, the variables. We have some options for some ClimateEngine assets that are preloaded. So if you want to do some summaries by states, counties, HUCs, things like that. Say we want to do a time series, return one of those. It's going to list all of our different endpoints. So we have, again, that native that's going to return every data point, the interannual, which is going to get those summaries during certain times during the year. And then we also have some standard indices and regression endpoints. If you click on the one you're interested in, so if we just time series native polygons, it's going to show you exactly what parameters are required, examples of how to fill them out, things that you can add that maybe aren't required, like buffers or masks and whatnot. So I've already gone to api.climateengine.org. I authorized my key, but I'm going to make sure that it works. And so if you go to authorize, input your key, and then you click execute on this, it's going to say your key works and you're good to go. I like using the Swagger page whenever I'm working with the API. It's really great for testing out different endpoints before maybe you build out your script. I'm going to scroll down to time series. or actually, let's go to zonal stats. So we have this group by climate engine asset. I'm going to try out. So this endpoint is going to allow me to summarize 2 different data sets by every single state. So we have a drought image. So that's what I want to group by. I have values and from negative 2.5 to 2.5. And so I'm going to bin those. I want to say, I want the population for every single binned amount. So I'm going to give them that static image. It will take in either an asset ID or value or URI from cloud storage. And so we have population here. I want to summarize it by US states. You could further filter by and say, I want to do it by these 3 states. So you'd say filter by name and then name the 3 states. I have to pick what band I want to group by. So I'm going to group by that standard index for 1 year. I'm going to summarize population count. This is going to be a continuous data set that I'm grouping by. And I want to get the sum. I want to know the total population within each of those bins. This is kind of that preset bin for the continuous drought data. And so we can click execute here. And that ran really fast. So now we can actually see the population within each group. So this is 2.5 and above is exceptionally wet, and then negative 2.5 and below is exceptional drought. And in here is going to be some like no drought at all, but you can see that it returns those values for every single state. So this is something you could return as a CSV to your Google Cloud Storage, or I can show some examples for the Python notebook. So for the sake of time, I'll switch to that. And so I'm going to do kind of the same workflow. You can do this in any Python script. I just like using Colab notebooks, especially for demos. They're easy to share, not as much worry with different environment things. So if you remember that double variable plot that we created in the app, we're going to recreate it here. So I'm going to just import and install all the packages I want to use for processing the data when it comes back from the API and plotting it. This is going to be where we're pointing towards that URL of the API and then also giving authorization through the key. I'm going to set up my first request. So I want native points. And then the parameters, my data set, I want to pull grid.mat drought. I want to pick that long-term blend as my variable. Start and end date. So we're going to go from 1980 to 2022, the end of 2022. I'm going to give it a set of coordinates, and I'm going to tell it what kind of reducer I want. And then I just have to create the request and store it in response 1. And so that's going to run. I can kind of talk through the next while it's going to do that. And then pretty much what I'm just doing after that is converting it to a pandas data frame. And then you could export it. You can filter the data to plot, which is what we're going to do. So we're going to say the date, this date, long-term blend. And so this is going to be the output. We have values. It makes sense that we're not going to get values for the first 5 days, first 5 years, because it takes 5 years of data for that long-term blend. And so we're going to do the exact same thing. We're going to make a second request. Only thing we're changing is that short-term blend as the variable. And then going to do this similar processing after that. And then we will plot them on the same. So you can see it's running pretty fast to return these blends. And so creating a plot, doing these 2 different values in different colors on different axes. And so we get this output. And people that are much more savvy than I can probably make very beautiful visualizations from these responses, but this is kind of the demo for all of those years. And so that is something that can be scaled. You can run these over multiple points, multiple polygons. You can do different looping and do different requests. So say you want multiple reducers or a bunch of different variables, you can loop over them and plot them all on the same graph. The second demo I wanted to show quickly is that group by that I showed with the Swagger page. So we can do things like pull this zonal stats via the climate engine asset. So I want to get the population in each heat stress category for each state. So I pulled Air 5 heat for earlier this year in January on the 8th. We're gonna, again, some population. We're gonna do regions and we're gonna filter by the name. Population, again, is our summary band, and we're gonna group it by those stress categories. And then so I did custom bins here based on the paper for what would be extreme cold stress, very strong cold stress, etc. So we'll make that request. And so you can see the output that's returned here. We'll do a little processing where we rename those buckets and do some summing. And so you can see the output, sorry for the control. But now we have every single state and we have the percentage in different heat stress categories. So a lot of these states, the whole state was experiencing strong cold stress. You could export that as a CSV, or we could do a little more processing to sort the name, things like that, and create a figure like this, where you can see kind of that percentage with these horizontal stacked bar charts of what percentage of these different states were experiencing these different types of stress. So yeah, you can see it can run pretty fast. You can export the files all within your Python notebook. I have one more that I'm going to show. So we can also do something where we look at maybe a sum of area. And so using the same endpoint, we add sub choices now. So looking at the top 5 producing states for corn, we can do something like looking at how many hectares of corn are in each drought category. And so we can make these requests, process them, and rename the columns. So now here we can see all of the different hectares. That's what we're doing this calculation here for all 5 states. So for that date, none of them were in exceptional drought, but Illinois had a lot of hectares. And then we can continue and create some visualizations where we can start looking for the state, how many hectares of the corn. So for Illinois, most of the hectares of corn were in some type of drought, whereas Iowa was a little more wet, showing some exceptional wetness in some of the areas. And so as I wrap up, we have a lot of these examples. So we have the support.climateengine.org. Here we have everything from getting started and using the research app, exploring all of the data sets that are available. Under the Climate Engine APIs, there's going to be API tutorials, some of the ones I didn't get to. You can kind of scroll through different outputs that you can get. Here, we combined it with groundwater level, pulling from the USGS and plotting them together all in the same script. So that can get you started. And then also we have some decision support articles. So you may be thinking, oh, these pieces are great, but how do I support decision making? And here's a really great example of using a peer-reviewed workflow to evaluate restoration outcomes, where you can start see some of the outputs that we built the pieces for. And you can see that this area productivity went up right around the time of restoration, even though there were some drier years. But then you can really get into things when you start looking at trends over different time periods and seeing something like this, where productivity was higher regardless of the amount of precipitation after restoration was done. And so I think that's a lot of the pieces. Let me see my PowerPoint. Yeah, so our support materials, you can go to climateengine.org for more information. That support site I just showed you. One last thing I'll say is this little blue question mark is how you can reach out to us. So if you're interested in a key, you think that there's a data set that could benefit a lot of people and you'd like it available, or if you just have a question about something, you can send it there. And we have a YouTube page. Eric Jensen does some really great walkthroughs. So if it was a little fast what I went through for making maps or creating graphs, you can head to our YouTube page and walk through those to really get the full breadth of what you can do. And with that, I will hand it back to